There we are. Welcome everybody. This is Kubernetes SIG API Machinery for open source. Today is February 4th of 2026, and we are having our bi-weekly meeting with a number of topics that we're going to go through. I will start with Jeffrey. Is that okay? If you're ready?
Yeah, sure.
Okay. So you can go ahead.
Yeah, would you be able to just click into the link
Yes.
on? Oh, actually, the link to the right side of that. Yeah, just show the cap. Cool. Yeah. Hi everyone. So today I wanted to talk about like this new proposal for shardable watches. So we know that there's a lot of events, or when there's a lot of controllers that read events from Kubernetes through watches. And as the cluster grows, we need to scale these controllers. And the traditional way has always been to scale vertically, adding more memory, making sure that there's more workers that are running the Go routines to sync. And essentially, the problem is that even as we scale these vertically, there are core resources, for example, pods that reach a significant amount of churn. So there's a lot of update events, and there's no way to partition the watch stream. The watch stream will still receive every single event. And some specialized controllers, like the Cube State Metrics controller, they implemented their own client-side sharding mechanism where they can shard their controllers based on a certain key, and then they're able to horizontally scale that controller. This has some limitations because every single partition still needs to watch the entire stream, and they end up basically receiving all the events for every single partition, and then they filter it the events client side. Cool. And so what I wanted to propose is this idea of sharding the watches on the server side, so that if clients were to want to horizontally partition their controllers, then they don't need to filter the events. So they don't need to watch all the events. They can just send the filter that they want to the API server, and then their stream of watch events will be filtered. Before I go into the actual details, I just want to say that this is we're trying to solve a bigger problem of like sharding controllers. And for example, KCM is one thing that probably we would want to look into sharding. But this is a quite a complex topic. So I want to start this CAD by proposing a simple building block to like these more complex topics like leader election and yeah, those other things. And so the design just basically goes over, I think the actual API is still in the works, but basically having a kind of a new field or some extension to the current field in our list options to be able to specify a shard key. So in this example I gave is UID, a range for start and end. And basically then every single partition will give their own ranges. And so this field will be hashed, and this hash would divide up the key space. And then the users can choose, or the clients can choose what kind of ranges they want for their particular hash, or for their particular shard. And yeah, that's mostly, there's like more details at the bottom, but I think I'll stop here and yeah, see if there's any questions, feedback, etc.
I have a question. So the Oh, yeah, Mo. So I remember sharding discussion, and it looks like Marek and I both remember the same one. I've linked an old presentation from January 10th, 2024. And there was a discussion of how to shard. And I remember that UID didn't work well as a sharding criteria because what happened is when you created some kind of useful controller that was going to act on A and B, more than one type, you ended up needing to have the items related to a particular namespace co-located in the cache. And so if you had a watch stream for one, and then you had no way to get the correct shard um, for, say, services. So services and pods, or replica sets and pods, or deployments, replica sets and pods. Then it didn't end up being a savings. Does that make sense? Because it seems like it still applies to me.
Yes. So I guess the premise is that every controller is different. Every controller probably cares about something different. So yes, a lot of the KCM controllers, they would want to probably look at, like, some of them are you're able to partition, let's say, by namespace. Some of them, there are more complex references with the owners. So technically, like, owner's reference could be some kind of sharding key. But I just wanted to sort of build out the foundation here. There are some controllers that don't have dependencies, and they do benefit from just using UID, like the CubeState metrics controller. But yes, I mean, that's a really valid point.
I guess I guess my memory of the previous presentation, it was extremely compelling that UID did not have forward growth potential. Um, that for a use case where you're watching a single object, it can do a thing. But in terms of growth potential, there's just very little that actually does that. Um,
So I believe this presentation focused exclusively on the control KCM. And I agree, yes. In KCM, there are very few controllers that benefit from specifically UID. But for controllers outside KCM, I do see there are a couple like controllers that are already doing horizontally sharding by UID. That and like at the end of the day, I think like this problem, there's a lot of research. It's hard to sort of have this like the full solution to it. So I'm trying to see if we can sort of work on this one problem incrementally.
right. I guess what I'm saying is that choosing an incremental first step won't that has no future for the majority of use cases isn't it's like an evolutionary dead end. So there are some that could benefit from UID, but I think the number of controllers that benefit from watching a single type is likely to be quite small. And so that
Mm.
leaves choices like I shard on one type and then don't shard on the others. Maybe. What if we instead started with sharding on namespace?
Yeah, yeah. Like I think I'm open to like what kind of any sharding key. Just yeah, want to sort of get the discussion started on just being able to like shard in general.
Sharding on namespace uh, would let you distribute the cluster across a certain number of controllers, but it likely wouldn't be well balanced. Um, I think you need to be able to shard on something other than namespace for cluster scope things. So UID and namespace as two things to shard on seem the clearest to me. Namespace would let you get distribution for controllers which need multiple objects at the cost of maybe not being well balanced if your namespaces aren't well distributed or you have a lot of objects in one namespace. But UID for cluster scope things or for single object things that don't care about namespace. I don't know. Supporting both UID and namespace as sharding keys seems like a better place to start.
Oh, okay. I'll amend the proposal. Yeah, and also like I would expect like the amount of shard keys to like for us to be able to add to it in the future, because there are a lot of like even for example, especially for pods like the node name, a lot of controllers would benefit from being able to like look at like those certain fields.
For controllers, for things that already have field selectors that let you partition the space, wouldn't we expect them to just use the field selectors?
Well, I think it depends, right? Because some controllers would watch the full stream and then select afterwards. Like because this is we're getting the items from the like controllers are getting the items from the watch stream.
Yeah, but field selectors work for the watch stream also.
Yes, they do. Yeah.
Okay. Reading Ben's.
Yes, Joe did bring up a point about cell-based selectors in my. I'm not sure if there was a past discussion on this earlier.
It was kind of related to Jordan's comment, which is like, are we saying that like intrinsic to the system, the API server knows what your cache or your hash or whatever your partition key is supposed to be, or is it something that you express into your filter request when you ask for information from the API server? I was kind of expecting something more along the lines of like the client asks for that and then expresses it somehow. And exactly how we do that we can talk about, but that's kind of what I was expecting. Like less we bake it into the API server where it knows intrinsically that pod is sharded this way, and instead the client say, I want pods sharded this way.
I feel like for built-in resources, we have to sort of have a list or like a fixed set of things to like not slow down the watch cache. But I'd imagine like for CRDs or other resources, like yeah, could probably custom define in the future.
Okay, I guess we all had different visions of how this would work. So in my in my mind, the client got to say, I am sharding on namespace. I am sharding into 13 shards, and I want shard 5.
Yeah, that is I think under this proposal, that is something that
And a different
we're
client
supporting.
could say, I'm connecting. I want to shard on pods. I am sharding into 7 partitions, and not 13. I'm sharding into 7, and I want partition 6.
Yeah, so to prevent like this kind of case where the server has to calculate this for everyone, we're trying to make it such that we provide just the hash and the clients provide a range of keys. So in this, I guess like hexadecimal like hash key space, the clients can choose however the partition they want. And so as a client, then they would specify like a range of keys, like let's say a set of keys that starts from 1 and with the prefix as let's say 1 to 4 or something like that.
Right.
And so if you have like 5, okay, let's say like the key space there was just say as like all integers, then if you were to partition it into 5, then it'll be like 1 watch is like 1 to 2, 3 to 4, and then 5 to 6, and etc. And then we can build client libraries to sort of make it easier such that the clients can just say they want like their shard 1 out of 5, for example. Does that make sense? We're trying to like
Sort of. I've now mentally gotten to the point where
in
I'm looking and saying like, oh, for namespaces, this works really nice. You can just plumb it all the way to etcd if you wanted to. And for I'm realizing for you that doesn't work at all. It's going to be completely reliant on a watch cache. Okay. I would read and think about it, I suppose.
All right, I think Fede has something he need to go. I'll continue with the rest of the meeting. Let me find the meeting agenda. So David and Jeffrey will let you guys sync offline and continue on this topic. And the next topic is Mo, right? Let me share the screen. Oh.
Yep, I'm here.
Let me share
Lost the window.
here. Yep. Do you want to share instead, or I can click into the link?
You can click in. That's totally fine.
All right.
So just as some context, so for a variety of reasons, we maintain a transport cache within client Go that's global to the process that uses basically connection level metadata, which effectively is the TLS bits, to sort of hold the transports so that when you keep making a bunch of clients over and over, it doesn't cause like unbounded connections, right? You get like connection reuse and stuff because you're reusing the transport. So this has had a long-standing bug of eventually leaking memory. It just doesn't tend to impact that many users because most of the time people don't just keep making these things indefinitely. So there's like two things in flight. One is my PR to start working through making it so that that global cache has GC. And so I implemented that GC using Go's new weak pointer support as well as Go's new runtime cleanup method, which is like a less insane version of finalizers that are much easier to reason about. So that appears to work fine. Last time I spoke with Jordan on this, I was going to work on updating the code to make it so that it was feature gated, and like when it's feature gated off, it would basically go back to using a non weak cache, and when it's feature gated on, it would keep using the weak cache. I also took the opportunity to fix the Go routine leak that the TLS reloading has here. So that will also get cleaned up now. The complication that sort of arises is that in parallel, we are working on making it so that we can support CA bundle reloading at the client side. Go makes that incredibly painful. In particular, the only sane way of doing that is to swap the transport itself, because you can't like swap the TLS config of a transport because it's not an interface and it's not like memory safe. It doesn't have any lock or anything you can take to change it. So with that in mind, I think the current plan right now is, and I realized I forgot to link the other PR, but we will work towards adding the CA reload support first, which will have its own feature gate. That will change our cache to be a reloading transport, so not a raw HTTP transport, but something else. And that will complicate my PR by making it so that it has to tolerate that. So it won't be nearly as small or easy to reason about by the end of it, I'm pretty sure, because I have to, I think, make it be much more careful about when it removes things from the cache than what it is doing today. But I think it's possible. I think that covers my context, but I mostly wanted to bring it up here in case like David, you or Joe or anyone else had any feedback or particular desires. In case you're wondering, I did base the implementation on how the internal TLS cache inside of the standard library works. So it's like a simplified version of that.
Just for reference, back in 2015, when I added this monstrosity to begin with, we did try to use the garbage collector finalizer stuff. That was where I originally wanted to go with the cache, but it wasn't reliable at that point. So the fact that Go improved it and is using it internally, and it looks like we can use the same mechanism, makes me really happy.
Yeah, I was at the same place. Right now, I see only the upside to this. So, I mean, I'll definitely read through the code, but thanks for doing it.
Okay. I guess I forgot one question. So I will certainly add the feature gate. I think both features will be enabled by default, I think, and both will be disableable, I guess, independently, I think, maybe, not sure. But that aside, is there any metrics on this that we would want? So the existing metrics tell you like when you get like cache hits and misses and stuff. I did expand that to also record when you get a cache miss when the weak pointer has become invalid but hasn't left the cache. So it sort of gives you some indication that, hey, you're having cache misses that are being sort of caused by the fact that we are GCing. And so that's could give you some information-ish, but I didn't know if there was any other metrics that people felt would be useful or appropriate.
Number of times this GC eviction fired, maybe, just to like if you're seeing a weird behavior and you're questioning, did this new thing cause a problem? Do I need to disable this feature? Like if the metric shows that actually it never even fired, like it's never run, maybe that would help rule out like, oh, okay, this never ran. That's not the cause of the weird thing I'm seeing. I should look somewhere else. That's the only thing I can think of.
Okay, so are you imagining just a counter?
Just an increment. Like how many times have we evicted things? I don't feel strongly, but if we're just trying to think of what questions would we want to know, like did it trip? Did it do a thing? That's maybe useful to know.
Okay. Yeah, I think that seems reasonable. I don't think that needs any particular labels, but I'll think about it.
Yeah.
Okay. Yeah, but I can add that. I think that seems fair. I think that'll at least let you eliminate very quickly that could this even be the root of the problem.
Did Mo's weird new function cause a problem? No, it never ran. Like, okay.
Yeah. I mean, I'm already well aware that I'll own any bugs associated with any change I make here, so it's kind of fine.
Now that's what I want to name the metric. Did Mo's weird new function cause a problem?
Okay. Well, I'm good. If everyone else is good. So. Thank you.
All right. Looks like you got what you need. Let's move to the next topic. Kennangaibel, you here?
Oh, yes, I'm here.
All right, let me click into this issue or pull request. All right, go ahead.
Okay, so I presented this issue in SIG Auth last week where it got support. So I created a PR, and yeah, I wanted to present it to this SIG. Basically, this change is inspired by a similar one where TLS server name field was added to the kubeconfig, and we want to have the same functionality in EgressSelectorConfiguration. The issue we're facing is that we want to route API server egress through a proxy, but the service to reach this proxy is not included in the SANs. So we can't make this work without updating cluster certificates for all clusters, which is a really big and tedious change. And so the PR just adds this TLS server name field.
All right. Yep, please take a look. I guess Jordan is probably already on that.
Yeah, Mo, I saw you left a comment on the PR about ALPN as well. You want to mention that while we're both on the call?
Yeah, so I looked through the capabilities we support in Client Go and such, and the two places for TLS that we support in Client Go that seem relevant here are one, the server name configuration support, and the other one is ALPN. So both of these things are sort of, like plain text values passed through the client hello at the TLS layer. The server name one changes both how the server can choose to route and interpret your request and what certificate it believes it should present, and it changes the client's interpretation of how it should validate that. In connectivity and other places with networking, I've seen ALPN used for similar reasons where you want to do routing, but you don't necessarily want to change any of the certificate semantics. Since I think the change would literally be one extra line, roughly, because we would just be passing the next protos through, and the default would be the default today, which is not set.
So in Client Go, the serializable config, the kubeconfig, doesn't surface next protos. If you're constructing one in code, like in the REST config, you can set next protos.
Yeah, I think that's right. I don't actually 100% remember, but I'll believe you. Yeah.
This would go further with the connectivity egress configuration than we currently do with like non-code constructed stuff in Client Go. I don't know enough to really have a strong opinion either way.
Yeah, I guess where I'm remembering it from is in connectivity where they use Client Go, they expose ALPN configuration and then wire it through to Client Go. That's what I'm remembering.
Yeah, maybe let's wait for an actual use case before we start adding more stuff to the config file. This gets us parity with the kubeconfig config file, which I think is a lot more straightforward.
Okay. Yeah, I don't feel super strongly. I just didn't want to have to come back here in like a month or something and be like, I would also like this other feature.
If we find a use case for it, we may need to add it both to kubeconfig and to this. So when we have a use case, let's talk about it then.
Okay, that seems fair.
Cool.
All right, thank you. We're ready to move on to the next topic. Marek?
Yeah, hi. I wanted to talk on a couple of topics, but high level, let's maybe start from an issue that was, I think, created some time ago about the resource size scalability dimension. I think high level that here we want to address the problem that we only current scalability tests only test validate very small objects, because at the one side Kubernetes promises to support 150,000 pods, but those pods can only be like less than or around kilobyte size to work, but users can still easily create objects up to 1 megabyte. So we would want to address this gap and have some alignment of we shouldn't, like, if there is a hard limit of the object size, we shouldn't provide we should target like 10% instead of like 1 promille of or less than 1/10% what is possible to user to set, because it's an easy dimension that can that user can push or not even know that they're pushing and break the cluster. So I went for a wild goose chase about how we can do that, and since then we are now running, like if you scroll to the end, now we are running continuous scale tests that test large resource. We after some tuning, we were able even to hit 3 GB pod resource, which means we had like pods of size of like 10 kilobytes, something like this, if I remember correctly. But we had, or I hit one problem that that is it's non-trivial in the current machinery for API server to send this amount of data within Kubernetes SLO. So as a reminder, Kubernetes defines healthy cluster, or like that as a cluster that is able to fulfill its several level objectives, as if it can return a list response within 30 seconds. Currently, this only fits if you have 2 GB of data, at least in our like official setup of scalability tests that we run on GCE. So the question is, can we do more, and can we get to like mythical 15 GB? And my answer is yes, but it would require some changes. So first, I discovered that the main bottleneck for sending the data is the compression that we do. So compression has been a problematic thing for a long time, mainly because it's the gzip standard library that we are using is much slower than anything else. So much slow that it is the first bottleneck that we hit. And the way that scalability tests solve it is that controllers that talk through localhost don't request gzip. So I don't think that's a greatest solution, because it means that if you grow your resource size to over like 2 GB, it will work, or like your pods, it will work for KCM control state for controller manager, but any other observer, informer, or any other controller outside of control plane will not be able to get this data, because the gzip compression will slow it down. So that's the one thing I would want to talk about, I think in the proposal, what we can do with that. The second thing is deserialization. So as much as we optimize lists, sending lists and serializing it, deserializing is pretty costly, and it's hard to do faster, or it's even impossible with the current list protocol. And third one is network. Like it's still a lot of data, so we need to. It would be great if we could reduce the size. So there is also something. And so my findings led to the watch list being currently like the fastest thing. So in 135, by switching controllers to watch lists, a lot of things improve. I think I wrote on the cap that we were able to get 3 times higher throughput if we just have controllers use watch list. If you can open the issue, the issue, yeah, that's. It should scroll to the last comment, or yeah. So we are getting like 3 times higher throughput just by using watch list. And this is because of 2 reasons. First, there is no compression for watch list, because watch doesn't support compression, which is great, or not necessarily. And second one is the fact that data is sent in chunks means that a client can deserialize it at the same time as server is sending it, so not at the end. So this makes it much as a protocol, it's much easier to send large amounts of data. So this goose chase led me to write a proposal that I haven't. I would want your feedback on, which is in the last issue. It is if we want to commit to a goal of having supporting large resources, or we can do that if we make watch lists, which is kind of everything, we should be moving to or controllers should be moving to watch list. If we could introduce a more efficient compression algorithm, so and basically anything outside of gzip to do compression for watch, and that based on that, I think I here proposed three things. Is that we should think about design enabling compression for watch, and I have a draft implementation and have some benchmarks that I could depending on which approach we pick, it's pretty simple. Second one, I don't think we can put we want to push dependency requirements on everyone, but having a way to register your preferred algorithm for compression would be great way for at least client libraries to not push the dependency on everyone. We could still have, even for any modern compression algorithm is not provided by the standard library, and any non-modern algorithm is much slower. It's mostly for background compression or compression of things. Anything that should for runtime compression, so things that are sending on the wire, to make it as fast as sending, you need a modern level. So I think there should be a way for someone to decide to register the algorithm without without pushing dependencies. And third, if we should pick some compression for some better compression for the built-in components. So here, if we have a way to register a compression, we could just add to the binary add dependency for the Kube API server and controllers dependency on the algorithm. Here, I think I changed or at least the difference that I would say is we should prefer an algorithm that is available in many languages, not necessarily S2. So things like Snappy, which is also provided by the same library but has different. But yeah, we should have some option to have a more newer algorithm than gzip built into Kubernetes. Yeah, so that's high level what's the context, and wanted to open for feedback and discussion.
I'll bite. We set this on the back burner after the streaming list. I don't remember what state we have left it in. I don't remember what's left to do to complete it off the top of my head. Do you have that list handy?
You mean streaming, streaming lists as a streaming compression, or are you talking about watch list?
We paused watch list because we had the streaming encoding, streaming collection encoding. And what I'm saying is I don't remember what is left on watch list to complete it.
So it's currently I think we paused it, then there was a document written by Wojtek, and we decided to still enable it in 135 because there were other benefits that streaming collections couldn't provide. So in 130, to my knowledge, and what I've seen in 135, it's enabled by default. So all clients using standards like client.go informers will use in 135 will use by default watch list and not list.
We did not convert list requests to silently use watch list. Only informers populating their initial set switched to attempt a watch list.
Yes.
So there's no intent to try to silently convert list requests to use watch list.
Okay.
The streaming list made the server more efficient at serving list requests. And I think that's about where we were planning to leave that. Watch list has better throughput characteristics, as Marek was indicating. And so the compression piece, I think we're happy with informers using watch list to populate their initial set. Like it puts us in a better position where we were even with streaming lists. And so if we could get the network bandwidth characteristics more similar to list network bandwidth, that to me seems like the last piece to make it like a win with no downsides. I'm not sure about the dependency thing. Like I really want us to be in a boring place with compression algorithms. I don't want to be at the cutting edge. I want to wait until there's a compression algorithm that is used everywhere and supported in every language and very, very thoroughly understood, and then use it for Cube. So I don't know enough about the algorithms out there to know, but I get really anxious when we talk about like, oh, we're discovering, or we're making use of algorithms that are maybe not super widely used. Finding one that has broad support across multiple languages seems good. Since we're constrained by what Cube API server supports, I wasn't really expecting us to try to support a lot of them and then let clients opt into like having it as a dependency. Hopefully it would be a small, safe, constrained dependency that Cube API server would build in, and we would be okay with just making part of client Go or API machinery. I know gzip was not great. Was that true even if we try to do some things to do it in parallel, to parallelize watch serialization?
You can speed up compression, you cannot speed up the compression. So I tested, and yeah, you can parallelize gzip, but you cannot parallelize, like, or at least there is no Golang library to do parallelize the compression.
Watches come across with each event being a chunk. It seems like each chunk could be a blob of bytes, and we could parallelize at the object level.
You can, yes, we could do. I don't want to go, or this is a huge rabbit hole.
Okay.
But we could. But there is two ways to do compression for watch. You can do stream compression, which would work like list, and you can do block compression. The problem with block compression is that you cannot concatenate the blocks. So currently we have we have a caching mechanism for serialization in API server for watch events. We could not implement same caching on at least on the same level for gzip, because gzip doesn't support, could not support concatenation, because you need more modern compression algorithm that supports framing. So again, S2 and Snappy support you to have frames. So the different why you need concatenation is because the current caching is on object level and not on watch event level, which is basically means nesting. So if you nest, you cannot nest things in like if you send block. Like if you are committing to blocks being watch event, you would then need to generate a compressed version of each possible event type, or at least 2 or 3 event types, 2 event types per each object, because one object in the watch cache can be sent as a add event or as a put or delete event.
Yeah.
Or update event. So, but at least it can live at least as a 2. So we would need to cache.
I really thought we had watch event level caching, but
it is, but it's for objects.
Yeah. Okay.
Like when things go to watch cache, we wrap it into cached object, and then we pass it to and put into the watch event, which magically reuses the when serializing, magically reuses the serialization.
Yeah. So maybe the questions I would ask are, what is the language support of the things we're considering? How standardized are they? How well proven are they? And is there a way to wrap things in a way that it can be like a layer that takes the existing objects or the existing bytes we're spitting out in each chunk, and it's like one more layer around it? Those are the questions I would have.
Yeah. So Snappy is 15 years old. I think it's boring. I said modern, but modern is still like 10 years.
Not gzip, which is 40 years old. Yeah.
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 But almost old enough for driver's license.
Yeah. Snappy is close to get.
Yeah.
Or yeah, in US.
Highlighting the language support and how stable it is, like how much of a standard it is, that would ease my concerns about whether it's appropriate to bring in. Also, there's the spec itself, but then also like the particular implementation we would be considering, because it's not a standard library implementation. Like, does it have assembly? Is it reviewable? Is it maintained? What's, how confident are we in the correctness of the implementation we're considering?
Sure, I can prepare that part.
Yeah, having that kind of written down somewhere would be really nice, because once we add one additional compression algorithm, somebody's going to show up later, be like, why not mine too? And I would love to not have to just be it because we don't feel like it type of answer. I'd like it to be because we have some criteria.
Yeah, that's having like I can work on both. Like it makes sense to have both criteria and thing. Okay, that answers my question. Maybe the last question about I wanted to ask is, are we okay? Maybe it's somewhat a scalability questions. Are we okay with saying that the only way to bootstrap an informer is using watch lists? Or for large resources, if you want to bootstrap your informer, you can only use watch lists, because we can it's fast enough? Or should we because it's by design like faster protocol, and we would relax the latency SLO for list for large resources? Or should we also like make the improvements to the list, or how to how to work with the word that we have one protocol that is faster and the other is slower, and we want to still increase the resource size that we are officially supported. Should it be a separate? I know SLOs are only for some size of.
Are you asking if the SLO has to be for the worst performing thing we have, or if we can list them independently and say, hey, there's a better SLO for this faster thing?
Yeah, because like we can speed up the list with, let's say we have a better compression, we can speed up the list, but it will still have much smaller resource size that we can support within the SLO using list versus watch list.
I mean, I think I'm curious what other people think, but I think if we're expecting one of these to perform better intrinsically because the way we built it, I think it's good to list them out separately so people understand that difference. That seems helpful.
Yeah. If we're wanting to have bigger resource sizes in our SLOs, I think it's reasonable to not say that we're going to keep our list SLOs the same while dramatically increasing the overall quantity of data pushed through it. So I think it's fine to say, list up to this amount of data in this time. If you want to have big resources, we expect a list of tens of thousands of big resources to take longer. The way you initialize informers and things is using watch list.
Okay.
It doesn't seem tenable to keep saying like, make the resources bigger and add more of them, and also expect a global cluster-wide list to stay within a 30-second, like a window we set with tiny, small numbers of things. That doesn't seem plausible.
Yeah, I agree. Also, Marek, it sounded like you were saying, do we invest in making lists faster where we can? That also seems good because we now expect there to be larger resource counts because there's going to be a set of mechanisms that support it. But I don't know what our options are. Are there, right? Like if it's like, do we support compression and do we only do it on watch list? No, we should probably do compression on both. But like, do we go through like some other set of complicated steps to try and make list catch up with watch list? I don't know. How we take that.
Yeah, I think that if I would go into like other side, which is how we maintain our SLOs, is I think, but it's more question to scalability, is we would need two tests with different resources. That one tests both list and watch list, but for smaller resource size, and one dedicated test for large resource size that no longer validates the list latency.
Or we accept a higher latency for a large resource with a large size. Like
a list will stop working because of timeout, or we want to also test higher timeout for list. Timeout is a minute, so yeah.
Yeah, so accepting a higher timeout than 30 seconds, or saying you have to do a paged list so that you get sub slices. If your individual size is bigger, maybe you have to shrink your page size. All of those seem plausible.
Mm-hmm.
But the main thing I care about is that you can actually start and initialize an informer even when you have a lot of a big resource. That's the main thing I care about.
Mm-hmm. Okay. That's all from me. Thanks.
All right. Anything else other than the things listed on the agenda? Anything in your mind you want to discuss, want to mention? All right. If not, I think that's it for today's meeting. Thank you very much. Good to see everyone. We'll see you next time.